Okay. So 7F is about true bearings. I will tell you this is a really weird kind of section and it kind of fits weird. So the first thing you have to know are your directions. North, south, east, and west. So true bearings are measured clockwise from the north. Okay, so to me, this little paragraph here is the most helpful. Say that you are in town A, right here, and you want to go to town B. If you face north from A, how far do you have to turn before you see town B? So this is 48 degrees. So we say the bearing of B from A. So that means we're starting with A. How far do we turn from the north at A to see B? And then we're going to use parallel lines. So let me kind of extend this. Lots of different ways to look at this. First of all, these are alternate interior angles. Those are congruent. What's a little more helpful is if this angle is 48, this angle is supplementary, same side interior. So if we took 180 minus 48, this angle in here is 132. So if I then wanted to find B from A, it's starting at B, facing to the north, traveling this direction, so I see A. If I know this is 132, I take 360 minus 132, and that's where the 228 comes from. All right, so what I would probably do is work on a couple of these problems here. So like 1A, it says show the bearing of B from A. So what I always do is start with A, draw straight north, then you're going to draw a 75-degree angle. That's less than 90. So that would be from B to A, where this is 75 degrees. So do the rest of number 1, see if you can do that. Check your answers in the back. Now, for number 2, everything is finding the angle from the north to the terminal side. So literally, this angle in number 2, 2A, the bearing is 126. In letter B, if we start from true north, we go all the way around. This is saying this is 165 or 65. So I'm going to add 180 plus 65. So it's just manipulating your angles to find the true bearings for each picture. So I would work on 1, 2, and 1, 2, 3, and 4. And then come back to number 11. Okay. So for example 11, we're going to go jogging. I'm starting right here. She goes 2 kilometers to the south. Okay, that should be straight. Just pretend. Then 3 to the west. So this should be a right angle if I go straight south and straight to the west. Find her bearing from her starting point. Okay, so if this is the distance I traveled, if this is where I start, what I want to do is find from here, straight north, over to the, where, from my, starting from A to go to look at B. So I need to find this particular angle right here because I know this is 180. Well, in our right triangle, this is why this fits in this chapter. Because if I want this angle, this is my opposite, this is my adjacent, so I'm going to use tangent of my angle, which will be 3/2. So then theta is tan inverse of 3/2. That ends up being 56.3 degrees. So if this angle in here is 56 and this is 180, my bearing is 56 plus 180 to get 236. Now, if you want to go and do some of the other homework having to do with example 11 and kind of come back, example 12 is probably the most trickiest one. Okay, so we're departing from A. And I always have to have my north drawn in, 136 degrees. So that's more than 90, but less than 180. I go this direction, 2.4 kilometers. And that's when I get to intersection B. Now, I'm going to draw this straight north because now I'm going to turn 226, which is more than 180, but less than 270. Here, let me make that a little longer. And I end at C. And I travel this way for 3.1 kilometers. So then I'm gonna, okay, that's probably not true. This isn't totally straight, just kind of not drawn to scale. Maybe we'll say that. All right, so the first thing that I want you to understand, let me get my angles in. This is 136. Can I find what this angle here is? Well, that's just my parallel lines here. So 180 minus 36, 136 is 44. And if this angle is 226, now find this inside angle. 44 plus 226 is 270. So that leaves an angle, this angle here, this is a 90-degree angle. This is a right angle. This is going to help us a lot. Because what do I know about all right triangles? The three trig functions plus the Pythagorean theorem. So if I know this side is 2.4, this side is 3.1, how can I find this hypotenuse? That's our distance from A to C. So AC squared equals 2.4 squared plus 3.1 squared. And then when I add these together, take the square root, do the math, I get 3.92 kilometers for this distance from A to C. Okay, now we want to find the bearing of C from A. So that means how far do I have to turn from here to here? Well, I know from here to here is 136. I just need to find this angle, theta. This is a right triangle, so I can do my opposite and my adjacent. So I'm going to use tangent. I don't want to use this value because this is an approximated value. So tangent of theta equals my opposite over my adjacent. So my angle is going to be tan inverse of 3.1 over 2.4. And we get 52.3 degrees. So if this angle in here is 52 and this angle here is 136, my bearing is 136 plus 52 equals 188 degrees.